Welcome back for another stream. We've got Jason, Christian, Chris, and Lisa joining myself, Dan, today. We're going to take on another exercism. We've decided to dive into the PHP track today, and specifically, we are going to take a look at not that one, but the change exercise, which is right here. And the general idea with this exercise here is that we're going to develop a method that receives an array of what would represent coins, so an array of values. Like here's a purse of change with these coins in it, and then the method's also going to receive a total value. So it'll be something like, here's a purse of coins, and I want 85 cents out of there. And I think our mission, if we choose to accept it, will be to determine in the fewest number of coins as possible, given what we have available to us, how can we return that value in change. And that's where we stand. So we have got things sort of set up to go here in terms of being able to run our tests. Jump through a couple hoops there, but I think we're good to go, and we are at a spot now where we can kind of like run our first test, and we see a failure that we expect to occur, and we can start on our implementation. So without further ado, why don't we get to it? If we look at our mob order, we have Chris navigating Lisa to start. Chris and Lisa, are you both ready to go?
Let's rock.
Okay. Sure. If you are ready, I'm going to start the timer, and off we go.
All right. Lisa, can we start off by, I think we're going to need a method called find fewest coins. So if we can start off by building that.
No nice way to do it. Okay.
Alright, so I think it's, they're going to take an array and then a number. Array and a number.
That's for now.
Cool. Cool. Perfect. Yep, that works for me. So let's...
Oh,
perfect. Yep, that works for me. Yeah, so let's... Oh yeah, it's awesome.
Just realized I was muted.
Run this and see what happens. Run this and see what happens.
I think you're gonna have another issue.
Yeah.
Right.
You're not in the class.
That might help.
Well, let's make a class then.
Oh,
So I don't think it needs to be a class,
Well, let's make a class then.
right? 'Cause I think it's just calling a find fewest coins method, isn't it? Yeah.
Yeah, there's no
Oh.
class. Here's your
Right.
All functions are by default.
Oh, right. It's fair. Cool. Let's try the next test and it's fair. See what we come up with. Cool. Let's try the next test and see what we come up with. No way. Who would have thought?
Okay,
All right. So it looks like we have to actually implement some logic. Who would have thought?
Oh man.
All right. So it looks like we have to actually implement some logic now.
Oh goodness. Gonna take the array. I'm gonna lose it.
Hi, kitty.
Dear. Oh, bad timing. No.
Hey, there's just a new mom.
I remember how to do this. I mean, use the collections.
Yeah, array as, and then
Mm-hmm.
the name you want to give each iteration of the.
Mm-hmm.
These coins already? Not really, there's a change.
I'd say each one is probably a coin singular, right?
Mm-hmm.
Yeah.
Mm-hmm.
Now find arrays. integer. And you return. That doesn't really tell you. It's just test change.
So it looks like we want like an array of what makes up that 15, right?
Okay.
So it looks like we want like an
Yeah,
array
so
of
it's
what
like
makes up
it's
that
giving
15.
you a purse containing a penny, a nickel, a dime, a quarter, and a loonie, and it's told you I want 15 cents out of that purse. So give whatever. So give me back the smallest number of coins that I need to get 15, which in this case would be a nickel and a dime, which would be 5.
I just wanted to point out for any non-Canadian viewers, a loonie is a $1 coin.
No, we're giving back a penny, a nickel, a dime, a quarter, and a crazy person.
Okay.
Not yet.
So what we can kind of do is like iterate and see if they're like the coin is bigger or smaller. Iterate and see if total that we need to make. Like the coin is bigger or smaller than the total that we need to make. If it's smaller, we can subtract it and then from the total and add it to an array. If it's smaller, we can subtract it from the total and add it to an array.
Time just went, yeah.
Okay, Jason, can you continue?
All right.
Level is, just try to get this test to pass.
All right. So what was your thought process here? We're gonna loop over each coin in this array.
It could be a totally bad idea if you have a better one.
I don't know. I was actually trying to think this through. I noticed that I'll start my timer. If we look here, like you can return the 4 penny coin. You can return it twice. I don't want to get ahead of myself, but like I guess with this one, were we trying to see if like, so we've been given 15. We would first look at the first thing here would be the penny. Like how? Yeah,
I'd recommend that you guys reverse the array maybe and go from.
That could be a good
good
place to start. So PHP reverse array reverse.
Well, that's handy.
Okay. Who would have thought, eh? Okay, so I'm going to take this, reverse this, and then can we just echo coin?
See what we're doing?
Yeah. Okay, so that looks good. So we've got a reversed array here. So now we're going to take a look at 15 and look at it against 100. We can't do much with that. And then 25 and then 10. So I guess, yeah, first we can take a look at like if the integer that's been given to us, if integer is less than or greater than, yeah, less than the coin. Let's just first echo the coin.
Skip those.
Take a look at
Or
that.
you wanna get those ones?
Yeah, I believe so.
Oh,
I think you might want the other ones, right?
it's the opposite?
Yeah. Thank you. Yeah, that was tricky. Oh, let me mute.
Some people are really excited about this change in the background there. That's great. That's
Yeah.
great. I applaud it.
Good support.
Yeah.
I think I heard write your test first. It's good advice.
I think that's what he's saying.
Yeah.
That's what he's saying.
Test-driven development. Right?
Not following TDD.
All right, so where do we want to take this next?
I don't know if I want to make the first test pass and just kind of return one that's equal to the coin and integer, or if you want to tackle the second test at the same time.
Because that first test will definitely fail now.
Yeah, so I guess you're right. We could do that. Like if we were to just simply return this, we now get
It has to equal though.
It's me an array. Also,
yeah. Thank
A
you.
few things are wrong, but you know.
Okay, so this becomes an array, and we're saying that equals, and then I'm still running just this. So if we were to run this, that passes. Cool. Run this. Now we're looking at.
we're returning anything. There's nothing equals. There's no 15-cent coin.
Yeah, exactly. So now we need to modify this. So if the integer is equal to the coin, so yeah, what we're looking at here is we're coming in with 15, so then we come across the 10. We want to be able to return a 10 and a 5 here.
I have a suggestion for how to proceed here. It won't hold up long term, I know that, but it'll get this test to pass at least. What we can do is once we're in, can you go back to the loop?
Yep.
You don't want me making a suggestion. What we could do here is we could say that go back to the original logic of if integer is less or greater than coin. What we'd want to say is that we'll want to build an object or build an array of coins outside the for each.
Yep.
And then we start adding into it. And then in each loop, we check, has this added up to our total yet? If so, we return. If not, we keep going. If that makes sense.
Yep.
I think alternatively, you could just subtract the coin from the integer. And then when the integer hits 0, you know you're done.
Do that too.
I think we are at a spot where we could use some of the dance moves of a former vice president of the United States. We need some of Al Gore's rhythm here. That was a bad joke. But if yeah, I think really what we're all driving at here is just having some kind of algorithm, right, to solve this.
I just got it. Al
Gore's rhythm.
Got him.
Yeah.
That's
I did
brutal.
not get that. I was like, what are you? What obscure reference am I missing?
All right. Release control. I've got Dan at the wheel here.
All right, Jason. Where do you want to go with this?
So did you have anything in mind in regards to our algorithm?
Well, yeah. So right now, do we have? I'm gonna actually just split these. I think so we don't have to tap.
Yeah, good call.
And then life's easier. Okay. So right now, what is passing? Nothing.
That's because we started rewriting it.
Yeah. So
yeah.
Like, if we receive this and we're reversing the algorithm and the target is 25, I wonder if we start at a spot of like reverse the array and then we step through it and say we start with like an initial target value, right? And anytime we add a coin to like our return purse, let's say, we subtract from that target, right? So let's say target starts with 25. We visit this coin and we ask, is this less than or equal to what's remaining of the target? No, right? So we can't return. So we skip to the next one. Is this less than or equal to? Yes, it is. Okay, let's put it in our return, and then let's decrement what's remaining, and then we keep doing that till it hits 0. Now, I imagine we're going to hit another implementation that's going to throw that off, but that's kind of where my mind went to at first.
Yeah, I like that.
That's where we were driving here as well.
Reverse array. Visit each item is item less than or equal to remaining. If yes, add to return and decrement remaining.
Yep.
And then do while or remaining greater than 0. All right, so I think that's kind of what we started with. We have a result. We reverse the array. I think this is our target. Does anyone mind if I rename this target?
Please do.
Yeah.
Maybe just slightly.
The first thing I was going to do as driver was to rename some.
Integers a little generic. We call this one array too. But, so that's our target. So we visit each one, and then we ask ourselves if the coin that we're visiting is, I mean, there's a couple ways you could do this, but let's say if it's greater than our target, let's just continue. And then otherwise, if we get here, we know it's not. So what we're going to do is push it into our return bag. Result rather. Coin. And then we can say target minus equals coin. And then I think there might just be an edge case there where we'd want to say something like if target is less than or equal to 0, we just want to break out of this loop.
Nice.
I don't know. Let's see.
Yeah, I feel like that should cover a few of the cases there.
Probably none of them will pass, but we'll see. Oh my goodness, one of them passed. Okay. So
There we go.
So we got a problem with one of them. I'm just going to get rid of this algorithm right now. So this one, the issue was, let's see. Oh, it looks like just a sort order. So it looks like the actual came back in descending order, and at least for this test, they were expecting an ascending order.
So we want to maybe just flip it back
I think
at the
we
end.
can just, whatever our result is, we can sort our result. I think that might do it. Yeah, that passed the second test. Perfect. So we're
Cool.
into some foreign territory here of the Lilliputian coins. So they have a 4 cent. I wonder what they call their 4 cent and 15 cent coins. But let's just target this test here. And we're failed asserting 2 arrays are equal. So what did we end up with? We returned 1 and 20, and they were expecting 4, 4, and 15.
Because it doesn't. Our current loop doesn't account for exact matching. It just goes through and gets us kind of as close as we can.
Yep.
Right, because our loop, we would visit this, we would pass it, bypass it, visit this, bypass it. We'd visit this, we throw it in the bag, we decrement, it's now down to 8.
No, we'd hit that 20.
Oh, we hit the 20. That's right, because it's less than the target, right? Yeah, so we put...
Thing that we haven't accounted for, which I'm just noticing, is I thought, and maybe everyone else noticed this, and I'm just a simpleton. I thought this purse was telling us we have 1 penny, we have 1 4-cent coin, 1 50. No, those are we have an infinite number of all of those.
Yeah. Types of coins.
Versions of coins. Yeah.
Well, this became harder.
Yeah. Plot twist.
It's funny. This was marked easy in the PHP track, but I'd say it's probably above easy if I had to guess.
The difficulties on exorcism make no sense. The easy ones are hard. The hard ones are easy.
Well, I mean, I don't know if you're ever trying to exercise somebody. It's difficult to get that demon out of there, but. All right. So Christian, I'm navigating you next.
Mother writes tests as well.
I'm navigating you next. Do you, or anyone for that matter, but certainly Christian, if you have an idea of how we might tweak our algorithm to account for this new thing we have determined. And I mean, another option too is we can leave this in place, copy the function if we want to try a different, comment this one out and try a different version of the function and come back to this. But I think we are thrashing a little bit at the moment on our implementation because and this is not uncommon, especially with these exercises where you'll get an implementation that passes a few cases and then you have that moment partway through. We've hit our first of those at least. So.
Yeah, I'm afraid I don't have an idea off the cuff.
I have an idea. I have an idea. So on where we're doing that check, if coin greater than target, and then we continue, right? And I think we were, like you said, we were initially assuming that this was the purse we got, and we only had 1 of each, right? But we have an unlimited number, right? And so I think what we need to do in essence is the problem was if we step through on line 22 in the test, if we step through those values, we hit 50, We said, well, that's bigger than 23. We bypassed it. We hit 20. We said that's less than 23. So we grabbed it and then we subtracted from 23. And then what should we have gotten back there? Actually, we should have gotten 15, 4, and 4, right?
Yeah, I think then this is going to be ugly at first, and I'm going to get it wrong, I think.
Yeah.
I think I'm literally just like spacing this out so I can see
more spaces, and we'll be good. There we go. Could sell some advertising.
What I try to do here is I will say while.
Adding those spaces remind me of like someone like getting ready to jump in like a breakdance circle. Be like, all right, get ready now. Get ready. I'm about to go.
So we could say while coin is over target. And I'm already like questioning if I'm getting these exact comparisons right.
I don't want to throw you off, but I do have an idea, so I'll let you kind of work this through, and then I'll share with the class.
Here, yeah. So what's our diff here? Yeah. So I think so if coin. Oh yeah, I've got these comparisons wrong. So while coin is less than target, is what I should have said. Now what's our difference? Closer. Oh, am I missing a less than or equals to? Is that all I'm missing like an idiot?
Mm-hmm.
Could be. No. I did get the right answer.
Yeah, the problem in this case with this data set is that it hits the 20, it says that's less than 23, and it grabs it. But then as it turns out, once it does that, then the only way then it can create 23 is by adding 3 1s, right? So then there's there's another permutation of values where we don't grab the 20, we grab the 15, right?
Yeah.
Right. That was my idea. I did get the right answer, but just not exactly the right answer.
So my thought was if we remove
Jason, Jason, are you sharing with the class now?
I'm sharing with the
All
class.
Right, please share with the class.
So if we remove the array reverse and kind of go the other direction and tried as many times as we could, I guess my thought was like if we had like a few different variants of like how we can match this and then took the one that had the smallest length.
Yeah.
Because ultimately we're trying to reduce the amount of coins, right? That's the goal here.
To build on that, what if we loop through and like found how many times each one went into that number, and then whichever one was the most, we subtract that first? Right? Or am I?
Well, I mean,
No, I think you're.
Am I doing it backwards?
If you're thinking that, Chris, what I would say is let's look at the test that's failing right now and walk through the data set in that test. Would that solve that problem? Right.
Well, we know we can get 2 4s out of it first, right?
Mm-hmm.
So 4 goes into it twice. But then, yeah, that wouldn't work after
One
that.
goes into it.
Yeah. No, I realized. Yeah, never mind. That doesn't work.
This is like I guarantee there's like if some comp sci student watches this, they'll be like, "It's so easy. Just implement the Hills-Meyer-Briggs equation."
Briggs-Meyer equation.
Sure, why not? But we don't. I'm at least me. I'm not a comp sci student. I didn't do any of that stuff. You don't typically need algorithms in web development. That's why this is fun. Like somebody out there, right, is like really, really mad that we're calling this an algorithm. Somebody out there's really angry that we're doing that. All right, that was my time up. Who am I navigating?
You're navigating me. All
right. Do you have any ideas? Because I don't.
I just said my idea and it wasn't a good one, so no, I'm out.
I'm entertaining suggestions from the mob at this point, but without said suggestions.
Yeah, I guess after saying mine out loud, it doesn't really make sense anymore. This is a tricky one.
You can just brute force it. Just randomly. But yeah, that's the interesting issue that we're running into is that there's more than one possible permutation of this answer. That's the struggle, right?
Mm-hmm.
Yeah. So yeah, I was trying to figure out like how can we get all permutations and then just return the one with the shortest length.
Mm-hmm.
Is that maybe an approach?
Yeah.
Like,
I mean,
I feel like this is just like factoring, is it not? Like, we're just finding the most efficient way to factor it.
yeah, really.
And yeah,
The issue is that we have a literally infinite number of each of these coins. So to get all permutations and pick the smallest one would literally take forever.
mm-hmm.
We got a new
I'm
follower.
pretty sure script timeout is shorter than forever.
That's exciting.
Oh, nice.
Mhm.
Jesus.
Oh, sorry. that was for a new follower. Their name disappeared, so I don't know. Don't know what their name is.
This is definitely a comp sci problem
Mm-hmm.
that like a bunch of web devs are trying to figure out.
Come on, we're smart people
I
too.
hate
Okay?
to-
we can figure this out.
I hate to admit that I have a degree in computer science at this point, but it's true, unfortunately. Well, here we are.
Mhm.
Yeah.
Mm.
This is one of those rare cases where TDD isn't yielding me much because
They don't build up to it, right? They just throw you right in
it's
the
like,
deep
all right,
end.
you need the solution now. All right, failing anything else, and I don't want to just sit here staring at camera. I say, let's look for solutions to this exorcism.
Cheater.
Little website.
Here, the other option is sit here and we look at the camera in silence.
I don't care that I cheat, Christian Griffin.
You heard it here first, guys.
Every day, man.
It would be interesting to, if we can find a more generic explanation of the solution, then actually try to implement it. That could still be a challenge. But
I do wonder if there's something on the description of the exercise that might give us some information.
Let's pull up the README. Let's pull it up on the internet. I think we still have that tab open. Just be easier
Sure,
to read
we
there.
do.
Software craft. So there's a coin change kata.
Maybe there is.
Tests. Don't try to solve the problem first. Well, we were doing that, but unfortunately, test number 3 doesn't really allow that anymore.
it's those Lilliput,
Test number 3 is like, all right, now have the answer.
those damn Lilliputian coins.
Damn Lilliputians.
Lilliputian coiner.
Google coin change kata and see if anything comes up. Any people who've had trouble with it. Oh, what is this one? Change for $1. GetLaura.com. Hey Laura, let's go visit this site. It's not secure. Oh, run away. They're using, is that Python?
Yeah, looks like it.
I don't see semicolons, so I'm assuming Python.
We definitely need to get change.
So how are they doing it? They are. And I'm trying to read Python. I've written a little bit of Python, but some of this I don't know. I don't know
Okay.
what the double brackets are. You see the double braces? I don't know what that's doing. I guess from context, I'm guessing it's putting coin into coin's return.
I think that's just naming the variable in each.
The
iteration
variable,
of the
yeah, I
loop.
think
No,
so.
not
Yeah.
not that. The double brackets or braces or fucking whatever. The triangles.
Oh.
Oh yeah, this is just
Yeah, this
inputting
is-
it. Yeah.
Okay.
Yeah, that's not Python. The end statements, maybe.
Could
Oh,
maybe
maybe.
Ruby.
Doesn't Ruby have semicolons, or am I crazy?
No, I don't think Ruby does.
Oh, well. Actually, that does look like Ruby.
Mm-hmm.
So there.
This looks like what we were doing.
I was about to say, this solution looks very similar to what we did.
Mm.
Now, granted, the exorcism won't be exactly the same as this kata that they're doing, but so they do empty array. They each over, and in fact they've even got the while that I had put in.
Mm. So yeah, this is pretty much exactly what we did.
Yeah. Now I'm interested. Okay, so we found that the kind of brute force, I'll say, code solution doesn't yield us the results we want. We down here find solution 2 let's use math, which I hate, but let's maybe just try and read this. I'm going to try and not read the actual math that she's doing in the code. I assume she, because it's called Get Laura, but I'm just assuming.
Okay, so we are dividing the remaining coins by the coin and then timesing it.
So I'm reading the paragraph up top. Quickly solve for number necessary coins with division and subtraction. So for 89 cents, 89 divided by 25 equals 3. I mean, it doesn't equal 3, but like there's a remainder. So it equals 3 with the remainder. Then I'm left with a certain amount. So we can try dividing. Yes, that's how we can do it. Okay, let's head back into our code.
Sure thing. I think it's time for me to nab Lisa, though.
All right. Well, do you see where I was going with it? We can start dividing it by the number of coins and incrementing through that way instead of what we're doing.
It's still kind of a loop.
Yeah, so I think we can just start making some changes to our original attempt.
That's really cool. So makes sense. It's kind of like what we did.
I saw his note for solution 3 there. I obviously haven't seen it yet, but
A better one?
well, I think there's other ways. I think recursion is there's probably a recursive solution. I don't know what it is for sure, but I'd imagine there would be.
Try this one.
Yeah,
I found that reading the paragraph up top helped me grasp what they were doing. So basically, they just divide it by. So they take what they're doing is they take a target and they divide it by whatever the coin is, whatever the denomination is. So in our case, we do. If you go back to the code for a second, we would do freaking Lilliputians. We would do 23 divided by 50. There's no whole number and then a remainder. It's 0, so we don't do anything with 50. Then we do 23 divided by 20, and it still doesn't work. God damn it.
How is this?
I think the problem with this solution here is that it's assuming that we're using standard denomination coins. As soon as we get into like the weird coins in test 3, this method doesn't work.
It's not that. This method would still work with the Lilliputian coins if the questions posed didn't have like multiple answers, one of which was the smallest possible and one of which was, more, but just like this problem here where we're running into 23 and then so you go backwards through it and you hit 20 and you go, oh, okay, we'll grab a 20 and then you only have room for 3 penny. You could potentially run into that with US coins as well, or Canadian coins, where you have your target is, I don't know, 28. And then you go backwards and you hit a quarter, and then that's probably not the best example because I think that would be the smallest number. But you see what I'm saying? Like there would be a scenario like that.
Mm-hmm.
I suspect that this Lilliputian coins one is an addition on the exorcism. None of the solutions we've seen for the katas would solve for this issue.
Mm-hmm.
Look for a different one.
Yeah, sure. Let's keep going. Let's keep looking for something that can help us.
There's no help for us.
I'm just hoping I click on something that is appropriate. And We can watch a video. Jeez, what's this now?
Interesting.
Gotta be easier to read one.
Yeah, so I think, and I think you talked about it too. There is probably a recursive solution somewhere too, where, because if you think about it, that method accepts the available coins and then some target value, right? So if we're stepping through it for that one, once we find 20, then our new problem becomes, how can I get 3 more cents out of what's left, right? Or once we had 15, how can I get 8 more cents out of what's left, right? So it just becomes sort of like a smaller version of the same problem, which made me think there's some solution there where then you can call the same method recursively and break it down that way, and then ultimately.
Yeah. So if you fill up the return array with all ones, and then you look at how can I want to replace these ones with bigger coins, right? So now say you have an array of 23 coins and you find yourself like replacing it with a bunch of 4s. Now you have all these 4s and a few 1s, and then you go through again and you replace some of your 4s and 1s.
No. Yeah, I see what you're saying.
That we come up with, I feel like we're going to run into the same issue where we end up with a 20 and 3 1s.
Yeah, it does feel to me like the ultimate solution here, like, does something to the effect that maybe there's more than one, but does something to the effect of like runs through all the different possible values and then says what's the shortest one, right? But how do you implement something like that? That's tricky, right? Because
either that or it's just a math solution.
like I think there's almost, again, going back to this one.
Oops.
If I just grab this keyboard for 1 sec. Going back to this one again, right? If we need a solution somewhere that says, okay, the solution we implemented puts the 20 in there and then puts, I guess, maybe 3 more 1s or whatever, right? And that's not the lowest number, because the lowest number is 15 and 2 4s, right? So we need a solution that says like, okay, can 50 go in there? No. Can 20 go in there? Yes, it can. Okay. So if we have 120 in there, what's the other combinations that could get us there? Okay. Can we put two 20s in there? No, we can't. Okay. Let's move on to the next one. Can we put a 15 in there? Yes, we can. What are the other solutions that can start with a 15? Can we put 2 15s in there? No, we can't. And we kind of move on like that, right? And then it'd be a lot to work through that algorithm, but I think something like that would get us there.
I think I'm building off what Jason was talking about with like an array of 1s. What we could do is keep adding the 1s together until they equal another coin, and then replace them, and then we move on from that one, add some more together, and then we try to add those 2 together. So like that's how we'd end up with the 2 4s. So we go through the first 4 1s, add them together, go through another 4 1s, add them together, and then see if we can add those 2 4s together to get an 8 coin, which doesn't exist. So then we keep going. You see what I'm saying? And then you might end up with like,
it's tricky how you get from the 4s to the 15 though, but I guess you would have some 1s left over.
Well, if you have the 2 4s, then all you have is 15 1s left over. You can compare that. Basically you'd always be comparing the 1s to, like, we'd subtract the 2 4s from the thing. I don't know. I'm just spitballing here.
I think what you're saying is interesting, Chris, in that, well, I was just looking, a number of the tests have a 1, but then some of them start to have a 2, right? But I think at least for these tests, what I think we're both saying in a way is that, like, for this one, there's multiple solutions out of these numbers that can get you to 23, right? The best one is the one that gets you in the fewest number, which is 15 and 2 fours. The worst one is 23 ones, right? So yeah, you start with there and then say, okay, this is the worst possible solution. Given what else we have, can we boil some of these down, right? Oh, let's try to add 4 of them together to make a 4. Can we add 4 more? Yeah, something like that. Yeah, there could be a solution there as well.
And I mean,
so then your array becomes, instead of all ones, you have 4s and 1s. And then you go through there again and you say, how many of these 4s can I put into the 15? Taking some of the 1s.
And we could expand that out to the other ones and just make the one, like basically not make it 1, but make it just the lowest coin value. So like for like the test on 30, it's 2s as the lowest. So we could just, no, I guess that one has 1s as well.
What if you have an uneven number like those 2s?
No, but there is a lowest coin in 34 that is a 1.
Would you have 999 in 2s? I guess you could.
Well, yeah, because you could have odd numbers with the 5, right?
Well, if
reflect?
I was gonna say, if somebody has a burning hot idea, we think we can make some kind of progress in the next round. Let's do that. Otherwise, yeah, why don't we just do a bit of reflection? All right, 1 second. There we go. Discussion scene. All right. So, yeah, I think first and foremost, we can reiterate that is not an easy exercise, despite what Exercism says. And this is funny. The reason I kind of thought of this one today was I had started working on this a couple days ago, but just did like the first test or two with our coworker Nick Down and friends. And when we chose it at that moment, Nick said, "Ooh, that one's not so easy." And so thank you, Nick. I heed your advice. But whether in a mob or not, I would love to see a solution through here that would get us to an answer. And yeah, these are always like,
it's a very interesting puzzle.
This is a solution that probably at the end of the day has some sort of loop within a loop or a recursive, it's like in Inception a little bit, right? You got to kind of start thinking like that, one way or the other. And I think this is probably, like that blog post was showing, is something where we could arrive at a solution using just straight loops or using recursion. But either way, it's a more difficult problem because you're thinking of loops inside of loops, I think, sometimes in your solution, and that can be tough to wrap your head around sometimes.
What I found interesting was that we arrived at a solution that was very much what everyone else on the internet had arrived at. And it seemed to work for them, and it doesn't work for us. And I feel like it's because there have been some extra kind of things thrown at us in the exercism that weren't necessarily in the kata that it originates from. So I'm encouraged by that, at least, is that like we were pretty quick about getting to what the solution ought to have been.
Another thing I would have liked to explore is, if you imagine this problem like in real life, if you actually had a drawer full of change in front of you and you would try to give this change back, you would go for the biggest coins, right? And I wonder if there's something there with trying to first grab, like if we look at the 15 example, first grabbing your dime and then grabbing your nickel. I wonder if there's something there where it's like you eliminate the largest ones because you can't make up the change with it.
Mm-hmm. Because
but the 23 kind of throws you for a loop there.
The largest possible coin, right? And that's I think what adds to the element of.
Yeah.
Mm-hmm.
Yeah. You're right. Because I guess that's kind of the direction we took initially.
And it seems to be the direction that everyone else took, which leads me to believe that the original kata didn't have that nature of issue in it.
Yeah, which is fun.
Yeah. I suspect that perhaps the original kata is what people were thinking of when they graded that one easy.
Well, humbling, but a fun exercise nonetheless, and definitely forces. I mean, a lot of these exercisms, right? They're very contrived
We tried.
problems, but I think they often, force you to expand your thinking about how you approach a problem in ways that then hopefully can be applied back to like your everyday work, right? Certainly, if we encounter a putting change Lilliputian coins issue on any of my client work, I know where to start at least. Cool.
We'll be ready for it.
Mm-hmm.
What about clients like, we want to offer this service to Lilliputians, and you're like, whoa, wait a minute.
Cool. Any final thoughts before we close it out for today? All right. This was fun. Cool. Well, thanks.
No, this was
for
fun.
joining, and thanks everyone for tuning in.
It was a good time.
And, yeah, we will keep on this one and come up with a solution for sure. All right. Well, until next time, take care, everyone. Talk to you soon. All right. Bye.